Hello friends, welcome to Data Science Lovers. In our last video, we learned about the I function in numpy library. In this video, we will learn about the identity function. First of all, we will see the definition of identity function, then the syntax, then we have to import the numpy library, and we will create a simple identity array of 4 by 4, and then we will use the integer data type for this array. We will check the dimension, shape and size of our array, and we will multiply our array with an integer value and a float value, and we'll see the result. Let's start. The identity function, it returns an identity array, or you can say a square array, with 1 on the main diagonal, and at all other places there will be 0. This is a simple syntax of identity function. From numpy library we have to use identity function, and inside this function we have two parameters, the shape and data type. These are few points about this function. First one is it takes a single integer value only as a shape. Okay, and the number of rows and number of columns will be equal to the given integer value. This integer value will become our number of rows as well as number of columns. And the default data type for this array, identity array, is float. Now, first of all, we will import the numpy library in this Jupyter notebook, and the syntax will be import numpy as np. The library has been imported in this Jupyter notebook. First of all, we will create an identity array of shape 4 by 4. As per our syntax, we have to use numpy library, then identity function, and we have to pass our first parameter shape, which is mandatory, while our second parameter dtype is optional. So I have to pass the shape, and for shape I have to pass only a single integer value. If I pass 4 here, this is how we can create a simple identity array. We will save this in a variable name a, and when I print a, you can see it is printing a 2D array of shape 4 by 4, and as per our definition, on the main diagonal 1 is present while all other elements are 0 here. For your reference, if we go through these 3 points, then first is it takes a single integer value only as a shape. So we have passed 4 here. Second is the number of rows and number of columns will be equal to the given integer value. So here the number of rows as well as the number of column will become equal to 4, which is our integer value. And last is the default data type is float. As you can see, all values of this 2D array are in float format. Now we will create the same identity array with integer data type. So how to create a numpy library, then identity function, and we have to pass the shape. Here I pass 4, and we have to change the data type. So I will use the dtype parameter here, and we will put dtype equal to int, means integer. We will save this in variable b. It is showing error. We have to pass the right spelling identity, and when I print b, you can see all the values are now in integer format, and the shape is 4 by 4. 1 is on our main diagonal and 0 elsewhere. So that's how we can create the data type also for the array. Now we can also check the dimension of our array a. This is our array a, and to check the dimension we have to use the ndim function or ndim command. Our array name a dot ndim, when I run this, you can see it is showing 2, means it is a 2D array. We can also check the shape of our array a, and the command is a, our array name dot shape. It is showing 4 by 4. Our array is of 4 columns and 4 rows. We can also check the size of array, and the command is a dot array name dot size. It is showing 16, means there are total 16 elements in our array a. We can also multiply our arrays with integer or float values. How? First of all, I will print a here again, And when I print our array A with an integer value of 21, what will be the output? You can run in your Jupyter notebook also. When I run this, you can see all the values are multiplied by 21. On our diagonal, there are all values 21 because it is multiplied by 1 and other values are 0. Similarly, we can multiply our array with a float value. Suppose I pass 3.1239 like this. When I run this, you can see all the values are multiplied by this float number, and this is the output as expected. So that's all friends for this video.